We ended the last video talking about leading coefficient. We're going to kind of pick up right there. But before I do, I want to kind of explain what we're doing this lesson. So we went over what a polynomial is. We went over the general form. We went over some definitions and some characteristics, talking about degree and maximum amount of zeros and terms. But what I want to be able to do by the end of this lesson is when I'm given these polynomials here, I want to have a rough sketch. So it might not be a perfect representation of that graph, but I kind of want to know how many times is it going to turn, where is it going to cross the x-axis, how does it start, how does it end. I want to be able to make a rough sketch given these polynomials right here. Okay, and so we're going to start that by talking about the end behavior. How does it start and how does it end? So when we want to figure out our end behaviors, we actually want to know, how does this graph end first? So it says if a polynomial function has a positive leading coefficient, which is again where we ended last video. If it has a positive leading coefficient, then the graph ends trending upward. So it will end going up. So I'm going to go over this, pause it and copy it down if you need to. As we go over this, we're going to fill these out right here. So positive leading coefficients, these graphs are going to end going up. So then opposite, if we have a negative leading coefficient, then the graph is going to end downward. So here we have negative leading coefficients. These end going down. So we want to start there. Once we figure out, is this graph ending up or ending down? Now I want to go back to the beginning and figure out, how does it begin? So if the polynomial has an odd degree, and again, from last video, the degree is the highest power. So here I have an odd degree of 5. Here I have an even degree of 8. Here we had an even degree of 6. So whatever degree we have, if it is odd, it's going to then the graph can be described beginning and ending in opposite directions. So it will either be like this or like this. Okay, so if I have odd degrees, they need to be in opposite directions. So if this one starts up, then this graph is going to end down. Odd degree, if this one ends down, then this one will end up. So then opposite, if we have an even degree and even end, the graph can be described as beginning and ending in the same direction. So either both up or both down. So here, an even degree, if it ends up, that means it's going to start up. Even degree, if this one ended down, it would also start down. So now we know how the end behavior is going to behave. If you like this more, you can use this. I personally like this more. This is what we're going to be referencing when we go to the next page. But this is also gold as well. If you have a positive leading coefficient and an odd degree, this is your end behavior. If you have a positive and an even, this is your end behavior. If you have negative and odd, end behavior. If you have negative and even, end behavior. So far, I don't know what's happening in the middle of these end behaviors. It might only loop, it might be a quadratic, it might squiggle a lot. I don't know what's happening in between these, but I do know how this graph starts and I do know how these graphs end. So let's apply this. I'm actually going to rip this real quick. Sorry, that was probably loud. Okay. And once I get my life together, okay, here's our next page. So example 2. Select one of the following 4 sketches that describe the end behavior of the graph of the given function. So here is kind of the thought process that you want to do. So if you fill this out, you're going to be able to get to your answer A, B, C, or D. So first we need to identify leading coefficients. And specifically, I want to know, is the leading coefficient positive or is it negative? So here, my leading coefficient is positive. Specifically, I'm going to put in parentheses what it is. It's that 3. So because I have a positive leading coefficient, that means my graph is going to end trending upward. So which of these graphs here, and there's 2 of them, have graphs that end going up? And that's C and D right here. So we are between, we have marked out A and B that end down. We know it's one of these 2 here. So now let's look at my degree. And when I look at my degree, I'm wanting to know specifically, is it odd or is it even? So what is my degree here? Is it even or is it odd? And I have an odd degree because it is specifically 5. It's x to the 5th. Now, when I have an odd degree, that means this begins and ends in opposite directions. So it starts and ends opposite. So out of my 2 options of C or D, which one ends and starts opposite directions? And that's D. So that's kind of the thought process that you're going through when you're trying to match these up. So going through it again, leading coefficient here, is it positive or is it negative of my f of x? Okay, this time it is negative. It starts right here with a negative square root of 2. So because it is now negative, that means my graph is going to end downward. So which 2 graphs end going down? And that's A and that's B. Now we look at the degree. I want to know, is it even or is it odd? Okay, it is even because it's x to the 4th. And when our degree is even, they start and stop in the same direction. So out of our 2 choices of A or B, which one starts and ends in the same direction? And that would be A. So please pause the video and see if you, well, before, I was going to say try C and D, but C is a little bit different because C, these 2, C and D, are in factored form. So we still need basically that first term here, and that's all I really need. We are looking at here because that tells me my leading coefficient and my degree. This tells me my leading coefficient and my degree. So what we need to do is just simply determine what that leading coefficient is, or that leading term is. So here I have an x squared, I have an x, and it's also going to be squared. So if I have 2 x's here and 2 x's here, I'm going to have x to the 4th plus, I have no idea what's going to be behind it. But again, all we're looking at is that leading term. So if my leading term here is x to the 4th, do we have a positive or a negative coefficient? That's positive. Specifically, it's a 1. That's a 1x to the 4th. So because it is positive, positive means it ends up. So which two graphs here end going up? And that's C and D. So now we need the degree. Is the degree even or odd? Okay, it is even. Typically, is that 4, x to the 4th. So if my degree is even, that means it's going to start and stop in the same direction. So out of my choices of C or D, which one starts and stops in the same direction? And that's C. You pause the video and see if you can determine what that leading coefficient is, or that leading term is. Okay, hopefully pause the video or you've had enough time to come up with an answer. We have -2 times x squared times x. That's going to give me -2x cubed. And then I don't know what happens behind that, but that is my leading term. So try pausing this video and seeing if you can fill this out. Hopefully you had enough time to either pause the video or fill this out. The leading coefficient is negative because it is -2. If it is negative, that means it ends going down. So that is graphs A or B because both of these end down. Then we need to look at the degree. My degree here is odd. Specifically, it is 3 because it's x cubed. When it is odd, odd and opposite both start with O. Those will start and stop in opposite directions. And so that would be B. One starts up, one ends down. Now, as I filled this all out, what I did was use this portion right here. But just to show you, you can use this right here. Once you realize, like on part A, that you have positive leading coefficient with an odd degree, you can come over here, positive odd degree, it needs to look like this. And so we said the answer was D, and it was D. You can come over here. This one has a negative leading coefficient with an even degree. Negative and even degree need to both start down. We said the answer was A, and it looks exactly like that is right here. You can also use this if you prefer this right here.